Hello everyone, I'm Divya, your math facilitator. So today we shall learn exercise 8.4. Okay, the first problem of exercise 8.4. So what is the question? Prove that the sum of the squares of the sides of a rhombus is equal to the sum of the squares of its diagonals. Okay, so you have a rhombus in this way. So ABCD is a rhombus. You know that rhombus all sides are equal. Okay, and just draw it neatly once again. So in a rhombus, all sides are equal. And what about the diagonals? Diagonals bisect. Okay, in a rhombus, diagonals bisect each other at right angles. So that is a property. So firstly, you should know the property if you have to solve this problem. Okay, so this is the rhombus and these are the diagonals. Okay, so in a rhombus, all sides are equal. So A, B, C, D and diagonals bisect each other at right angles. So this is point O. Okay, now, so here you can see you have four right angle triangles. Yes or no? You have four right angle triangles. See, AOD is one right angle, COD one right angle, AOB is another right angle, and COB is all these are right angles. Yes. So I am using Pythagoras theorem. Okay. So using Pythagoras theorem, in all the sides. Okay. So you can write. See, in triangle AOD. So you can write. So where is the hypotenuse? Hypotenuse is the side opposite to the right angle. So AD is the hypotenuse. So AD square is equals to OD square plus AO square. Again, this is the right angle. So side opposite to this is hypotenuse. So in triangle AOB, you can write AB square is equals to OA square plus OB square. Now again, this is the hypotenuse in this triangle. In triangle BOC, I can write BC square is equals to OC square plus OB square. Now in this triangle, in triangle COD, I can write CD square is equals to OC square plus OD square. So you got four equations, equation 1, equation 2, equation 3 and equation 4. So add all the equations. So let's add all the four equations. Why are we adding all the four equations? Just see what you have to prove. You have to prove that the sum of the squares of the sides of the rhombus. Okay, squares of the sides are AB, BC, CD and AD. So square of the side, sum of the squares of the sides. So that means AB square plus BC square plus CD square plus AD square. Okay, so this is the sum of the squares of the sides. So all the sides I am squaring and I am adding together. That is equal to, you have to prove that that is equal to sum of the squares of the diagonals. Okay, the diagonals are nothing but AC and BD. So sum of the squares of the diagonals. Okay, so now here you see AB plus BC plus CD plus AD you have. So see AB plus BC plus CD plus AD. So adding all this I have to get the answer. That is the reason I am adding all the four equations. So AB square plus BC square plus CD square plus AD square. All the four equations adding you will get this. AB square plus BC square plus CD square plus AD square is equals to OD square plus OA square plus OA square plus OB square. Add all the equations. Plus OC square plus OB square from the third equation, and last equation is OC square plus OD square. So here you can see you have OD square here and OD square here. So 2 times OD square plus OA square is also 2 times. So 2 times OA square plus OB is also 2 times. So 2 times OB square plus OC is also 2 times. So here we can write this as AB square plus BC square plus CD square plus AD square is equals to 2 times OA square, 2 times OB square and 2 times OC square. So 2 you can take common. OA square plus OB square plus OC square plus OD square you can write. Okay. But what is OA? See here, OA is nothing but half of AC. We have learned that diagonals bisect each other. Bisecting means dividing into half. So OA is half of AC. So I am writing it here. So OA is half of AC and you have a square, OA square, isn't it? Now what is OB? OB is half of BD. You have a square. OC is again half of AC. You have a square plus OD is half of BD. Okay, since OA is equals to OC is equals to, it is half of AC and OB is equals to OD is equals to, these are half of BD. So now simplifying this, you'll get the answer. So that is equals to 2 times. So 1 by 2 whole square is 1 by 4 and you have AC. So AC square by 4 plus BD square by 4 plus AC square by 4 plus BD square by 4. So AC square you have 2 times. Okay, so 2 times AC square by 4 plus BD square also you have 2 times. So 2 times BD square by 4. Here 1 2 and 1 2 gets cancelled. So you have again 2 times AC square by 2 plus BD square by 2. If you distribute, what will you get? 2 and 2 gets cancelled. You will get AC square plus BD square. Now what is AC square plus BD square? AB square plus BC square plus CD square plus AD square. That means sum of all sides, squares of all sides is equals to the sum of the squares of the diagonals. Question number 2. ABC is a right angle triangle and right angle at B. So you have a triangle ABC, right angle at B. Okay, and D and E are points, are any points on AB. So here you have a point D, here you have a point E. Okay, these are any points on AB and BC respectively. Okay, so join these two. So now you have to prove AE square. AE square means I have to join AE also. I want AE square. You have to prove AE square. So let's join AE square plus CD square. That means I have to join CD also. AE square plus CD square is equals to. So what you have to prove? To prove AE square plus CD square is equals to AC square plus DE square. This is what you have to prove. So here right angle triangles are given to us. Okay, so I am taking triangle. In triangle ABC. Okay, if you take triangle ABC, see how many right angle triangles you are getting. Triangle BCD is also right angle triangle. Okay, right angle at B. So if you take that, so CD square is equals to, hypotenuse square is equals to BD square plus BC square. Okay, so let this be equation 1. Now if you take another triangle, so in triangle ABE, this ABE is also a right angle triangle. So here what do you have? AE square is equals to AB square plus BE square. Now you might ask how will we know that we have to take these triangles only? So how will you know? You will know from the question. Okay. See the question. AE square you have. Where is AE? This is AE. Okay. So with respect to AE, if I want a right angle triangle, this is the right angle triangle I'll get. Okay. So I took ABE. Now next I want CD square. Where is CD? See here. CD is here. This is the hypotenuse. So with respect to that, this is the right angle triangle. So these two right angle triangles I have taken. Clear? So always from the question only we will go. Nothing new. We will not do anything on our own. We have to go by the question. So now add these two equations here. These two are added, isn't it? So add these two. So AE square plus CD square. I'm adding. So what will you get? BD square plus BC square plus AB square plus BE square. Now go back to what you have to prove. AC square plus DE square. Where is AC square? Where is AC square? See here. AC square is here. This is the hypotenuse of the bigger triangle. So AC square I can write it as, so AC square is the hypotenuse of triangle ABC. So in triangle ABC, AC is hypotenuse. So AC square is equals to AB square plus BC square. Okay. Now DE, where is DE? D is the smaller triangle. So in triangle BDE, in the smaller triangle, DE square is equals to BD square plus BE square. Okay, so that means if I rearrange this, just see, I want AC square. For AC square I have AB plus BC. AB is here, BC is here, so I'm writing them together. AB square plus BC square plus I want DE. For DE you have BD and BE here. Okay, so BD square is here, BE square is here. I'm just writing them together. Okay, that is equals to, you know, AB square plus BC square is AC square plus BD square plus BE square is DE square. Hence proof. Got it? Let's move on to the next question, question number 3. So prove that 3 times the square of any side of an equilateral triangle. So you have an equilateral triangle, okay, A, B, C. So square of any side of an equilateral triangle, okay. So square of, you have to prove, square of any side of an equilateral triangle is equals to 4 times the square of the altitude. Okay, 4 times square of altitude. That means I have to draw a altitude now for this equilateral triangle. Let me draw. So altitude is nothing but the height. Okay, so this is, I am taking as point D. You know that in an equilateral triangle, median, altitude, angle, bisector are all the same, isn't it? So if I am drawing AD is altitude, then AD is also median. Okay. So now let's take these two triangles. So now altitude is dividing the triangles into two parts. Okay. So in triangle ABD and triangle ACD. So you know angle ADB is equals to angle ADC. This angle is equals to this angle. How much it is? It is 90 degrees. Okay. And angle B is equals to angle C. These two angles are equal because in equilateral triangle all the angles are 60 degrees. Okay. So using angle similarity, what can I say? Using angle similarity, I can say that triangle ABD is similar to triangle ACD. Okay, so when the two triangles are similar, and not only similar, you can prove that they are congruent also. Why here you see, I'll just prove it. So two angles are same, just see, two angles are same, and two angles are same. And what about AB and AC? AB is equals to AC. Since it is an equilateral triangle, the side is also same. So using ASA congruency, two angles and one side, using this congruency, you can say that these two triangles are congruent to each other. When the triangles are congruent to each other, what about BD? BD is equals to DC. These two sides are also equal to each other. Okay. Otherwise also, if you don't want to prove this, you can simply write one statement. What is it? In a right angle triangle, all the sides are equal and all the angles are equal. They are equal to 60 degrees, and altitude, median and angle bisector are all the same. Okay, so if you are drawing an altitude, the altitude itself is the median. That means D is also the midpoint. Okay, so that you can prove. Now here also you have to prove the same. BD is equal to DC means you have to prove that D is a midpoint. But from the properties also you can write it. Okay, if you don't want to write it from the property, this is how you prove it, that these two are congruent, and you will write that D is a midpoint. Clear with this? So once you write that D is a midpoint, so the next step is, so just see here. So D is a midpoint. Okay, that means BD is half of BC and CD is also half of BC. So if I am taking this side as A, this side as A, so this side is also A units. So BD is half of BC because both are, D is a midpoint, isn't it? So that means half of BC is half of A. Okay, this you have taken it as A, isn't it? So this is half of A. Now take in triangle ABD. I'm taking the right angle triangle ABD. This is right angle, isn't it? So hypotenuse square. So AB square is equals to BD square plus AD square. Okay. AB is nothing but A square is equals to BD is how much? Half of A, isn't it? Half A square plus AD square. Okay. Clear? So a square is equals to 1 by 4, or you can write a square by 4 plus ad square. Send a square by 4 to LHS, so you'll have minus a square upon 4 is equals to ad square. So ad square is equals to, taking LCM, 4a square minus a square is 3a square by 4, or the same thing I can write it as 4ad square is equals to 3a square. Okay, 4ad is nothing but altitude, isn't it? So 4 times square of the altitude, 4 times ad square is equals to 3a square. So it is square of any side. So 3 times a square. See, 1 second. Read the question 1 second. Prove that 3 times the square of any side. Okay, so 3 times the square of any side is equals to 4 times the altitude square. So that is what we got. Clear? So let's move on to the next question. Question number 4. So PQR is a right angle triangle at P and M. Okay, so you have a right angle triangle PQR. PQR. This is right angle. So you have right angle at P and M is a point on R. So M is a point on QR. Okay, such that PM. So if you draw PM, if you join this, so PM is perpendicular to QR. So show that PM square. So you have to prove PM square is equals to QM into MR. So what will you take? See here. Here also I'll tell you one easy method. PM square. So this square is equals to QM into MR. So which two triangles are you finding here? See, if I join this, this is one triangle, this is the other triangle. So I'm taking these two triangles. Getting the point? Okay, so in triangle PQM, so you might be confused, ma'am, why these two triangles? So that is the reason I'm drawing first. Okay, what you have to prove? PM square is equals to QM into MR. So if I join this, these are the two triangles. In PQM and triangle PMR, we know that angle PMQ is equals to angle PMR. Angle PMQ is equals to angle PMR. How much is it? It is 90. Okay, it is 90 degrees. And you can also see that. Okay, so angle here you see 1 second beta. Angle PQR we shall take. Okay, we shall take the bigger triangle PQR. Okay, so yes, PQR and PQR and QMP. Okay, so 1 second. So we are taking triangle PQM and PMR, isn't it? So here in these two triangles, we know that angle PMQ is equals to angle PMR. Let me check if there is any other easy method to tell you. Yes. So the easiest method I'm telling you, if a perpendicular is drawn from the vertex of a right angle triangle to the hypotenuse, if you are drawing a perpendicular, then the triangles on both the sides are perpendicular to the whole triangle and also to each other. Okay, if a perpendicular is drawn, if you are drawing a perpendicular from the right angle to the side opposite to the hypotenuse of a right angle triangle, then the triangles on both sides of the perpendicular are similar and also they are similar to the whole triangle. Okay, so see here, I'm drawing a perpendicular from the right angle to the hypotenuse. QR is hypotenuse. So now this perpendicular divides the triangle into, see, this is first triangle, second triangle and the bigger triangle, original triangle. So these three triangles are similar to each other. Okay, that is the condition. So if you want to use it, you can use it. So if you say that, madam, we don't want to use this condition, so you can use the other condition also. So here I am directly stating you the proof. What did I state? I'll just write so that if you want to use, you can use. Okay, so if a perpendicular is drawn from hypotenuse, drawn to the hypotenuse beta. So what are you doing here? You're drawing perpendicular to the hypotenuse, isn't it? So perpendicular is drawn to the hypotenuse from which point? From the right angle. Then, then it divides. It divides the right angle into two similar triangles. Okay, here you can see triangle 1, triangle 2 I named. So there are two similar triangles and they are also similar to the bigger triangle. This is the statement. So I'll also prove the statement. Don't worry, I'll also prove the statement. Okay, if you want, you can use this. Otherwise, we shall prove the statement. So how are we going to prove? So if you directly take the statement, you can say that therefore triangle PQM. Okay, this triangle 1 is similar to triangle 2. Okay, when the two triangles are similar, which implies PM by this PM by then the next part is QM, isn't it better? Let me draw the triangles, it will be easy for you. Okay, right angle it is at M. Right angle is at M. Okay, and here you have which point you have C. So right angle is at M. Here you have PQ. PQ as one triangle, and here you have PR as one triangle. Okay, so PM by, let me take the triangles. See here. So understand the statement. The proof we will be using in the next question also. I'll tell you how. Okay. So yes. PM by QM is equals to, what can you take here? So this is 90, isn't it? In triangle PQM, okay, M is 90, and also in triangle PMR. Okay, so this I am taking it as M, R and P. Okay, so you can take it as Rm by, so see here. So let's take the corresponding sides. So here you can take MQ by MP is equals to, okay, MQ by MP is equals to PQ by PR is equals to PM by RM. Okay, so take these two statements. Okay, what will you get? See, I'll write it here. So MQ by MP is equals to PM by what is this? The last one, what did we write? It is RM. Okay, PM by RM. So what we want, PM square is equals to QM into MR. So cross multiply. So you will get MQ into RM is equals to PM into MP. PM or MP both are same, isn't it? So I can write this as PM into PM. Okay, is equals to, here in question it is given as QM. Is it MQ or QM is same? RM or MR is same. Okay, so this I can write as PM into PM is PM square is equals to QM into MR. Okay, why did I took this here? Just see better. If you take PM and PM, they both gets cancelled. Okay, so the triangle you have to take it this way. PMQ. This is one triangle PMQ. Now this triangle is to the left of this. Okay, so one triangle is facing this side, one triangle is facing this side. So the hypotenuse I am reversing. See, M is 90 degrees, so that you will write it as constant. And instead of PR, you will write it as RP because you are taking the reverse of triangle. One triangle is this side and one triangle is this side. Clear? So this is, if you use this proof, you can directly say they are similar and use this. If you don't want to use this proof, so fourth problem, method 2. So how will you do? So you will derive the proof and then you will use the same statement you will have to derive. Okay, so how will you derive? Just see. So you have this triangle P, Q, R and M is the perpendicular. So P is also 90 degrees. So firstly, I am taking the smaller triangle and the bigger triangle. Okay. So in triangle PQR, the bigger triangle, and triangle MPR, smaller triangle. Okay, the bigger triangle and smaller triangle. See, angle P is equals to angle M is equals to 90. Yes or no? This is 90 degrees in the bigger triangle and smaller triangle. This is 90. And angle R is common in both the triangles, isn't it? So using angle criteria, what can you say? So therefore using angle, I can say that triangle PQR is similar to triangle MPR. So you got the smaller triangle is is similar to the bigger triangle. Okay. Now let's take the second case. So in triangle PQM, okay, and triangle PQR. Now I am taking the second smaller triangle, this triangle and the bigger triangle. So here also the same point, Q is common, angle Q is common to both the triangles, and angle P is equals to angle M. It is 90 degrees. So using angle criteria, I can say that triangle PQM is similar to triangle PQR. Okay. So now see the statement. So this is 1, this is 2. So in 1 you have triangle PQR is similar to triangle MPR. In 2 you have triangle PQM is similar to triangle PQR. That means this triangle PQR is common. Triangle PQR is similar to two triangles. So you can say like A is equals to B is equals to C. This B is common. So you can write A equals to C. So similarly, therefore I can write triangle MPR. This smaller triangle is similar to triangle PQM. This smaller triangle. Okay. So you got two smaller triangles are similar to each other, and also the smaller triangles are similar to the bigger triangle. Clear? That is the same statement which we wrote it there, and here we proved it. So once you prove this, okay, now you can again use the same, this one. Okay, so now you can use this. Clear? From this step again it is same. Okay, so if you want, I'll write it again. So therefore when the two triangles are similar, see here, because the two triangles are similar, you can write MP by MQ is equals to PR by QP is equals to MR by MP. Okay. Now I'm just taking these two because I want PM square, isn't it? So you will get PM square is equals to QM into MR. Okay. So that in detail we have written in the previous slide, isn't it? So please check the previous page also. And in the previous method, we have used this statement and taken the similarity. Okay, and I did this in detail. Now here we have proved the similarity. Smaller triangle is similar to bigger triangle. Second smaller triangle is bigger to bigger triangle. And so both the smaller triangles are similar to each other and they are similar to the bigger triangle. So you can use this and you can prove this. Clear? So let's move on to fifth bit. Fifth bit is again the same. Fifth bit is again the same. Fifth question. So you have right angle triangle. Okay, here I will do it directly now. So this is A, D, B, C, and you're dropping AC is perpendicular to BD. Okay, so you have to prove AB square is equals to BC into BD. See, AB square is equals to, where is AB square? AB square. AB square is equals to BC into BD. So which triangles you will take? You take the bigger triangle C. This triangle you take, and also this is the half, isn't it? Take this triangle also. Yeah. So let's do it. So in triangle ABD, okay, you want in triangle ABD and CAB. I told you how to take. How are we taking? Using the prove required to prove only. Okay, so these two are similar, already we have proved. Is yes or no? So in ABD, angle A is equals to angle C is equals to 90 degrees, angle B is common. Okay, so therefore triangle ABD is similar to triangle CBA. When they are similar, what happens to the sides? So you can take AB by BD. Okay, see this AB by BD. Okay, so I'll just draw it here so that it will be easy for you. So you are taking A, B, D. A is right angle and C is right angle, isn't it? C is here. So you are taking BA. So AB by BD. See here. In triangle ABC, this is BD, isn't it? So AB by BD is equals to, I can take this as BC by AB. Okay. See here. AB by BD. I'll just mark the points once again, it will be easy for you. See, these are the two triangles which we have taken, ABD and CAB. Yes, so in these two triangles, so angle C is 90 degrees, angle A is 90 degrees. So the side opposite to angle A is what? It is BD. Okay, BD. Clear? But it is in this side, so let us take it as BD here. Okay, so this is B, this is D. Here because we are taking the mirror image. Here it was this side, now you are taking this side. Otherwise, you take it the other side only. Okay. Now that is equals to, what are you getting here? C is the right angle. So this is the hypotenuse AB. Okay, so you are twisting it in this way. So you will get AB in this way. Okay, so C, it is in this way. So you are twisting it. So you will get AB in this way. So now let us see AB by BD is equals to BC by AB. See, AB by BD. Now the two triangles are similar to each other. AB by BC. Let's write it. Okay, AB by BC. Again it has gone. We're taking it as B and D. Okay, A is 90 degrees, opposite side is B and D. So AB by BC is equals to, well, here you can take it as BD by AB. Both are hypotenuse. BD by AB, that is equals to, the other side is AD by BC. Clear? So now what do you want? Okay, AD by BC, AB by AC, this has to be AC. Okay, AD by AC is equals to BD by BC is equals to AD by BC. Now take any two, so you have to prove what? You have to prove AB square. Okay, so if you take these two, what will you get? AB square is equals to AC into BD. Okay, you will get AC into BD, but you have to prove BC into BD. Okay, so that means these sides we have to take little different. Okay, so just see here, the first one which we have taken. See, if you take this as D and B, so you will get AB by BC. Okay, then you will get it correct. Getting the point better. So there is no hard and fast rule that this you have to take in this way, this you have to take in this way. We always go by the question. Okay, so in the question you need AB by BC. See, I have checked, I'm not getting the answer, so I'm just changing the vertices again. Okay, so AB by BC is equals to BD by AB. Hypotenuse will be clear. Hypotenuse is side opposite to the right angle. So this AB and BD is clear. But which side is AD, which side is AB is the confusion which we always have. Okay, if I take this as D and this as B, this is the adjacent side. AD is adjacent and AB is adjacent. If I'm reversing the points, if I'm taking this as D and this as B, so AB will be the adjacent or the base and this will be the perpendicular. Okay, so always the confusion is with base and perpendicular only. In trigonometry also we will learn. But there, with respect to an angle we are taking. So here what you will do? You will take with respect to the question which is asked. Okay. So in the question you want to prove AB square is equals to BC into BD. So I am taking D here and B here and I am checking my answer again. So AD by AC is equals to AB by BC is equals to BD by AB. So now if I take these two, I am getting the answer. AB square is equals to BC into BD. Got it, beta? Let's see the second bit of the same question. So you need to prove AC square into BC into DC. AC square is equals to BC into DC. So let's take the triangle A, D, C, B. Okay. So you have to prove what you have to prove. AC square. Okay. This AC square is equals to BC into DC. BC into DC. The same question which we have done in fourth bit. Okay, we have taken these two triangles. You have proved that these two triangles are similar to each other. Yes, so this is same as fourth question. So please try it by yourself once again. So let's see the third bit. So this is A, D, B. This is C. So this is 90 and this is also 90. So here what are we doing? Just see. So here you want AD square. This AD square is equals to BD into CD. BD is this, CD is this. Okay, so which two triangles will you take? For CD, you have to take this triangle. For BD, for the complete BD, you will take this triangle. Okay, so one big triangle and one small triangle. Getting the point? So in triangle ABD, that is a bigger triangle you are taking, and in triangle CDA, smaller triangle we are taking. Okay. So we know that angle C is equals to angle A is equals to 90. Angle D is common. So triangle ABD is similar to triangle CDA. Both triangles are similar. So when they are similar, corresponding sides are equal. So I am drawing the triangles again. You don't have to draw it in your examination. For your understanding, I am just drawing it. So angle A is 90. So this is A. I am taking this as B and D. And this is what? This is angle C is 90. And you are taking the triangle CDA. Okay. So now I am writing the corresponding sides. AB by CD is equals to AD by CA is equals to BD by DA. Okay. So what you have to prove? You have to prove, let me write it here. AD square is equals to BD into CD. This is what you have to prove. Okay. So if I take these two, AD square is equals to BD into, I want CD. Okay. That means I have to interchange these points. Okay. So come on, let's interchange these points. So I'm writing it this as B and B. We are taking it as B and D, isn't it? So take it as B and D. See, AD by DC is equals to AB by CA is equals to DB by DA. Okay. So now take these two because you want DA square. Okay, I'm writing it here. So DA square is equals to, so AD into DA is DA square, or you can write AD square is equals to DC into DB, or you can write as BD into CD. Now you got it, beta. Why am I taking? So depending on the question we will take. Okay, so here we are not getting the answer, so I'm not taking those sides. And also one more important tip I will give you. Okay, instead of drawing the triangles, you might say, ma'am, we draw the triangles in tension, we will confuse more. So here itself I'll tell you the trick better. Here itself I'll tell you the trick. Just see. So you have AD square, right? AD square as AD into AD is equals to BD into CD. Okay. So transfer BD to one side. So you'll get AD by BD is equals to CD. One AD transfer to this side. So it goes to denominator. So see, that is what you have taken, AD by BD. See here. AD by BD is equals to, yes, AD by BD. See, AD by BD. we have taken the reverse order, is equals to CD by AD. So this triangle I have taken first and second. So if you take the reverse order, this is nothing but AD by, see this one, AD by DB reciprocal is equals to reciprocal of this also, CD by AD. Okay. Now if you cross multiply, you'll get the same answer. So what am I doing? So instead of drawing the triangles and getting confused, from the question itself, you will get this statement. Okay. Directly, you can say that these two triangles are similar and you can write this statement. Okay. Write this statement and cross multiply, you will get this again. Same trick you can use here also. Okay. What is the trick? See here, you have to prove that AB square is equals to BC into BD. Okay, so it is AB into AB. So AB into AB, one BC I'll take it to this side and BD I'm keeping to this side and one AB I'm taking to this side. Okay, so just see AB by BC is equal to BD by AB. So without any confusion, you can directly write this step. Since two triangles are similar, you can go back to this step, write this step, and you can write hence proof. Clear? So this is one shortcut, or you can say one trick, so that you can avoid mistakes in your board exam. Clear? So question number 6, from question number 6 I'll teach you in the next class. Okay, do practice these once again. So use the trick, it will be super easy for you. Clear? So I'll meet you all in the next class, but don't forget to practice.